Welcome back. This is the first lesson of week 16. In week 15 you learned all about recursive functions. This week you'll learn about two important tasks you can do with recursive functions. In this lesson you'll learn how to create a trace table to trace a recursive function, and in lesson 16.2 you'll learn to write a recursive function. So in this lesson, we'll recap what you've already learned about making trace tables. You'll look at how we handle the parameter and the returned value of a function in a trace table. Then we'll work through how to trace a recursive function, first doing a worked example, and then I'll leave you with an exercise. As a reminder, when we make a trace table, we number the lines of the program or algorithm. We create a table with a column for each variable, and then we create a row that shows the changing values at each line. Let's create a trace table for an ordinary non-recursive function. This example is an iterative function. So let's make a trace table that matches this function. Pause the video, get out your paper and pen and begin to draw the trace table for this function. Remember, there should be a column for each variable in the function. So I'm just paused to give you a chance to get started on that. So your table should be starting to look something like this. We begin obviously at line 1, and there are 3 variables: text, which is the parameter coming into the function, and 2 local variables called new text and first. So I'm going to start filling those values in. So let's try filling the values in if the parameter that is sent to the function is the text string ABC. So let's start to build that trace table. So at line 1, the parameter text has the value ABC. At line 2, obviously text still has the same value, and a value is assigned to the local variable new text. It's given an empty string as its initial value. At line 3, none of the variables change value, so I'm not going to include it in my trace table, but notice that length of text is greater than 0, and therefore we do continue with the loop and we go on to line 4. At line 4, the local variable first is assigned a value. It's given the value of the first character in the variable text, which is the letter A. And now we've gone to line 5. Text is given a new value, all the content of the text variable starting at character 1. That's the second character. So it now has the value BC. That's overwritten the old value of that variable. And one final line to look at for now. Line 6, new text is made from the character first plus the old value of new text, which is an empty string. So A plus an empty string, so it's just the letter A. We now go back up to the top of the loop to line 3. Line 3 is still true because the length of text is greater than 0, and so we're going to continue. So see if you can finish that trace table. I'll show you the completed trace table in a moment or two. So the completed trace table looks like this. It's we can see text going down to until it's an empty string, at which point the loop stops and the function is completed. We could simplify the results of this trace table to say that when my function is called, it has as a parameter the string ABC, and it returns the value CBA. It's pretty obvious that the function has the effect of reversing a string, but that's all shown in full in the trace table, but I'm simplifying it to this simplified table, which just shows what goes into the function and what value comes out of the function. So now let's turn to recursive functions. Remember that a recursive function opens a new copy of itself, and that copy in turn will open new copies. And so you get many versions of the function opening in memory until you reach the base case. Each of those new versions has new variables, new parameters, and new returned values. So basically, if we're going to trace a recursive function, we're going to create lots and lots of trace tables, one for each version of the function. So here's a function, it's a recursive function. So let's look at how we might trace how this would operate using a trace table. So let's trace this function. If it's called with the parameter ABC, like the last function that we looked at, and it opens in RAM, a version of the function opens in RAM. So let's trace what happens inside that function when it runs. In line 1, the parameter ABC is passed and it's captured by the parameter text. So ABC, the variable text, has the value ABC. Lines 2 and 3 are the base case. If the length of text is 1, that's the base case. Well, the length of text is not 1, is it? It's 3. So we skip 2, we skip 3, and we're at line 4. At line 4, text still has the same value. The variable first is assigned the first character from text, so it has the value A. And at line 5, the variable rest is given the value of the rest of the text variable, so BC. So now we've got, we're at line 5, text has the value ABC, first has the value A, and rest has the value BC. So what is the returned value of this function? What is returned is the result of my function called with BC plus A. We don't know what that is because we haven't run my function with the variables BC. So we've got to go on and call another version of the function within memory, and that opens now as the second version. So to recap, my function with the parameter ABC has a returned value which is my function BC plus A. We can't return that value yet because we don't know what my function BC is. So now we're going to have to run it. So now we run my function again, but with the parameter BC. Let's find out what the returned value of that is. Here it is. We're calling it with the parameter BC. So in line 1, text has the value BC. We can skip lines 2 and 3 because they don't apply and go directly to line 4, where first is given the value B, and line 5, where rest is given the value C. We're now at the end of the function, and what we have to return is my function with rest as a parameter plus the value of first. So that is my function called with the parameter C plus the letter B. But we still can't finish our function because we don't know what the returned value of my function with the letter C is. So we're going to have to call it a third time. So this is where we are so far. My function called with ABC needs to know the value of my function with BC, and my function with BC needs to know the value of my function with C. So we're calling it for a third time. This time we're calling my function with the parameter C. So what happens when we do that? Well, at line 1, text is given the value C to match the parameter. At line 2, the length of text does equal 1, so we go on to line 3 and return the value C. We return the variable text which holds the value C. So our returned value is C. We don't have to call the function anymore because we've reached the base case. So what's happened inside computer memory? We've opened my function 3 times. Firstly with the parameter ABC, secondly with the parameter BC, and thirdly with the parameter C. That third time is the base case because it returns just the simple letter C. It doesn't call any more versions of the function. So that is the returned value of my function C. And that returned value is passed to the version of the function where it was called. And we can substitute my function bracket C is C. So C plus B, in other words CB, is the returned value. And that's passed back. So the result of my function BC is CB. So let's substitute that. CB plus A is the returned value. If we fit those together, CBA. So the returned value of the entire chain of functions is CBA. In other words, this chain of recursive functions has reversed the text string, and it would work however long the string is, but we've just done it with a string of 3. So that shows you what is going on inside the computer's memory when a recursive function is called and then calls more versions of itself. Values are being passed down the chain as parameters and back up the chain again as returned values. So to recap, you know how to make a trace table, add a column for each of the variables in the function and a row for every point in the function where one of the variables changes its value in any way. You looked at a simplified version where we just show the parameter and the returned value of a function and how we can fit these together into a chain of parameters and returned values to show how multiple copies of the function will open in memory. So in this lesson, we've looked at a recursive function. Build this function in Python. You can just copy the code that we've shown and run it a few times, and you'll see that it reliably reverses any string, reverses the order of all the characters in a string. If you're my student, you'll also find a document of recursive trace table exercises, and we'll carry those out in class and work together on those. Okay, so that was quite a difficult lesson, but I hope it's taught you something about what's going on inside the computer memory when we run a recursive function. In the next lesson, we're going to look at how to write a recursive function. So bye for now.